Hello, good day viewers. Still on definite integrals. Today we are going to learn how to find the area bounded by two or more curves. If we have a function f of x greater than another function g of x, the area bounded by the curve of f of x and g of x is nothing but the integral from a down to b of f of x minus g of x with respect to x. And how can we determine the limits a and b? We can simply do that by equating f of x and g of x. Once you equate, then you solve for x, you will determine the value of a and b. So today we are going to find the area bounded by the curves y equal to x squared minus 4x and y equal to x. This is a quadratic function while this is a linear function. Before we start, I would like to sketch both functions. This one is a linear graph, right? Because it is a linear function which passes through the origin. It has a slope of 1. So we have something like this. And what about this one? The moment you set this equation to be equal to 0, you have to obtain the values of x to be either 0 or 4. So we have 4 here, we have 0 here. So it passes through this. Something like this. I'm just sketching. So in order to find the limits, we need to find the points of intersection where the two graphs intersected. And to do that, you can simply take this one and equate it to be equal to this. So let's do that. If I have x squared minus 4x equal to x, we are equating the right hand sides. The moment you bring this one in, we have x squared minus 5x equal to 0, because negative 4, negative 1 is negative 5. This is the same thing as x minus 5 equal to 0. You can see that x could either be equal to 0 or x equal to 5. So it means that they intersected at this 2 point, the origin as well as this point 5. So to find the area bounded by the two curves, which is this region, all you have to do is to integrate the function. You can clearly see that this is our what? Y equal to x. That is the straight line, while this one is y equal to x squared minus 4x. So you can see that x is above, while x squared minus 4x is below, which means that this is greater than this. So we take the limit from 0 down to 5, because they intersected at 5, of what? X, which is above, minus the function below, which is x squared minus 4x dx. So once you integrate this function, you shall obtain the area bounded by the two curves. So let's do that. So this is the same thing as the integral from 0 down to 5 of the function x minus, once you distribute this negative sign inside, you have minus x squared, then plus 4x dx. And we have this, and this will give us 5, right? So this is the same thing as the integral from 0 down to 5 of 5x minus x squared dx. So now let us integrate. You add 1 to this, it becomes 2. You divide by 2. So this becomes 5x squared divided by 2. You add 1 to this exponent, it becomes 3 minus x to the power of 3 divided by the same exponent. Then limits. All we have to do is to substitute the upper boundary. So we have 5 instead of x, we have 5 again squared divided by 2, then minus 5 again to the power of 3 divided by 3. Okay, let me move to the other side. So we have 5 squared, which is 25, times 5 is 125. 125 divided by 2 minus 5 to the power of 3 is 125 again. 125 divided by 3. And once you simplify this, you take this, you multiply by this, you take this, you multiply by this, you subtract, then you divide by 2 times 3, which is 6. This will give us 125 divided by 6. And hence, this is said to be the area bounded by the curves x² minus 4x and the x. Thank you for watching. Do share to your learning colleagues, and don't forget to subscribe to my YouTube channel for more exciting videos. Bye-bye.